Okay, it is time for the thrilling conclusion of example 4. So we did put together our pooled standard deviation of the error, and now we have to go to the standard error of the difference. And so once again, just like our equation, we're going to take our pooled standard deviation, and then we multiply by the square root of the inverses of our samples. So I'm going to take 1 divided by sample size 1. I'm going to add to that 1 divided by sample size 2. I don't have to worry about parentheses in there because the division happens before the addition. And so we end up with our standard error of the difference is 1.142. And so now we are dealing with this difference between our populations. So we're dealing with this mean. So we are going to use a t-test. So that means that we're going to be using the t-value in our t-distribution. So we're going to go here, and it is going to be our, it's going to be our one-tailed t-test. So we need to actually figure out the t-value, and so that's going to be the sample mean difference, 1 minus 2, minus our hypothesized difference, which is going to be 0. Put all that on top, and then I'm going to divide that by the standard error of the difference. So standard error of the difference. And that parenthesis is the wrong way. That's going to cause it to crash. And so our t-value is 2.387. And aside from our t-value, we're going to need our degrees of freedom. So our degrees of freedom are going to be do it with the sum. We've got our sample size 1 plus our sample size 2. We're doing the difference, so it's going to be minus 2. We've got 78 degrees of freedom. And so now the big payoff, we're going to go to our t-distribution. And we are going to be looking at the right tail because we're going to be looking at everything to the right, everything as it gets bigger. So we're going to be using tdist.rt. We're going to use our x, that's our t-value, and then our degrees of freedom. We have 78 degrees of freedom. We're going to close that up, and we are going to run that. So why did we do? We've got a p-value of 0.01. Is there statistical evidence that the exercisers are more productive than the non-exercisers? Since our hypothesis that we're testing is exercise minus no exercise is greater than 0, this is telling us that we are at the 1% confidence level. That is fantastic, 0.01. That's telling me that there is strong statistical evidence that employees who exercise have higher I have problems typing and talking for some reason, have higher ratings, and these ratings are productivity ratings than those who don't. So if we were running our company and we saw this, we'd be doing everything that we can to get more employees to work out 3 times a week. Maybe bump those numbers up. And so there we go. Another example of hypothesis testing with the difference between sample means. If you have any questions, please let me know. And otherwise, I will talk to you next time.